Hello guys. Okay, before we start with the topic we will discuss later, I would like to introduce our group members. The first is Muhammad Syahid Aminin bin Saharuddin and the second is Muhammad Aidil Shazwan bin Abu Bakar and I Harid Daniel bin Hairun Nizad. We are from group A4AS 1202GR. Okay guys, so what I want to discuss in the MAT183 subject is related to the topic application of differentiation is analysis of function 1 and 2. Okay, the first topic selected is analysis of function 1. Okay guys, in this slide, I would like to tell you about introduction analysis of function 1. Analysis of function 1 is a polynomial function. For example, graph of a quadratic function or graph of a cubic function. Analysis of function 1 involve increasing or decreasing, concave up or concave down of a function and inflection point. Okay, for analysis of function 1, it have a few steps to solve the equation about analysis of function 1. The first step is find the x-intercept, which is y equal to 0, and x-intercept, which is x equal to 0. The second step is find the intervals, increasing or decreasing. The third step is find the extremum point. The fourth is find the intervals, concave up or concave down. And the next step is find the inflection point. And the final step is sketch the graph.
Next, we're gonna solve the problem regarding for this topic. The given example here is fx equals to x squared minus 4. For question A, they want us to find the x-intercept and the y-intercept. For question B, we need to find the interval where the function is increasing or decreasing, and then we need to find the extremum point. And for the question C, we need to find the interval of concavity and also the inflection point. And for the last question, we need we need to sketch the graph using all the above informations. Let's start solving. For question A, we need to find the x-intercept and the y-intercept. For all we know, if we want to find the x-intercept, the y-axis is going to be 0. So y equals to 0. From the equation, we put the as 0 and we can get x equals to 0, negative 2, and 2. For y-intercept, it's just the same as the x-intercept, but this time the x-axis is going to be 0. So we put the 0 value on the equation, and we got x equals to 0, y equals to 0. And that's how we solve question A. For question B, we need to find the interval when the function is increasing or decreasing, and then we need to find the extremum point of it. To do this, we need to put the equation as a whole first. For example, fx equals to x squared minus 4. We can simplify it if we can simplify it. So if after the simplification, we can get x cubed equals to 4x. With this simplified equation, we need to find the f prime x of it equals to 0. So after we do it, we get 3x squared minus 4 equals to 0. With this equation, we can find the critical value x, which is 1.15 and negative 1.15. That's going to be the critical value of our interval. Next, we see this graph. We need to make this graph based on our information given. The first column going to be the interval. The second column going to be the test value. And the third column going to be the sign of f prime x. So in the first row of the first column, we can put the range from negative infinity to negative 1.15 as the first interval. For the second interval, we can put negative 1.15 to 1.15. And for the third one, the last one, we can put 1.15 to infinity. And then for the second column, we can need to put the test value, any value inside the interval range. For the first row, we can put negative 2 inside of the range. For the second row, 0. For the third row, 2. And then using this test value, we need to see what is the sign of f prime x after putting the value inside the equation 3x squared minus 4. After doing the calculation, we can get the first row of the interval, we can get positive value. Second, negative value. And the third one is the positive value. This can help us to find the increasing and the decreasing of interval. We can put it like this. Fx increasing in the interval of the positive, the row with the positive signs, while the negative value at the row with negative value gonna be the decreasing interval. We can write it like fx increasing in the third interval of positive value, negative infinity to negative 1.15 with the union of negative with the union 1.15 to infinity. The same also happen in the for decreasing interval. Fs decreasing in the interval of negative 1.15 to 1.115. And that's how we get the decreasing interval and increasing interval. The maximum point is based on the interval also. From this observation, we can get negative 1.15, 3.08 as the maximum point, and 1.15, negative 3.08 as the minimum point. That's how we solve the second question. For question C, we need to find the interval of concavity and also the inflection point. To do this, we need to find the inflection value first. The inflection value can we get by using f prime x of the equation. After the calculation, we can get 6x as the f prime x. Then we solve it to get the x equals to 0. We got the inflection value, we can do the concavity test. Just like the interval, we can put the table to get the to just like interval, we can put the table to do the concavity test. It's just the same method. The first column gonna be the interval, the second column gonna be the test value, the third column gonna be sign of f double prime x, which is 6x. But then we need to add one more column as a conclusion. Either the graph is concave up or the concave down. Let's start. The interval for the first row is the range from negative infinity to 0 based on our inflection value. And for the second row, 0 to infinity. And then we put the test value for both of the interval. The first one going to be the negative 1, the second one going to be 1. After we put the test value inside the equation f double prime x, which is 6x, the sign of the first row going to be negative, and the sign for the second row going to be positive. As a conclusion we can make, if the sign of the f double prime x is negative, it's going to be concave down. It's going to be the reverse smile graph. While for the positive sign, it's going to be concave up, which is the smile graph. And then with this, we can find the inflection point is 0, 0. Because with all with all information that we got from the above from the previous slides, We can now make the graph of fs equals to s squared minus 4. First, we sketch a graph line, and then we put the s-intercept and the y-intercept of the value. For this equation, it's going to be easy since it's 0. So we can put the point at 0, 0. And next, we're going to find the interval of the graph. The interval from range negative infinity to negative 1.15, it's increasing. And then it stops at 1.15. While from negative 1.15 to 1.15, the interval is going to be decreasing. So it's going to be downward. And for the 1.15 to infinity, it's going to be increasing. It's going to be upward again. So you're going to be like the maximum point and the minimum point is going to be the sign where the interval going to happen. For this equation, negative 1.15 and 3.08, and also 1.15 negative 3.08 going to be the point the interval start. The first point is the maximum point and the second point is the minimum point. With all this, we can see the flow of the graph already. That's when we need to do the inflection point. The inflection point is the shape of graph we need to do. The inflection point we got after the value is 0, 0. This is quite a simple equation actually. So based on the concavity table, negative infinity to 0, the interval, have the negative sign of double prime x, which also conclude the concavity down. So from negative 1.1, negative infinity to 0, the graph gonna be like that, the reverse smiley face. For the second one, 0 to infinity, 0 to infinity, I'm sorry, the sign of f double prime x is plus. It's gonna be concave up and do the smiley face. And then after the sketch, we can get this as the graph. That's all for problem solution 1.
Okay guys, we are done to discuss about analysis of function 1. So the next topic selected is analysis of function 2. Okay guys, we are done about analysis of function 1. So I would like to talk you about introduction analysis of function 2. What is analysis of function 2? Analysis of function 2 is a rational function which is fx equal px per qx, where px and qx are polynomials function and q not equal to 0. Rational functions have horizontal asymptote and vertical asymptote. An asymptote is a straight line that a graph approaches without touching. Analysis of function 2 use graph of rational function. Okay guys, for your information, analysis of function 2 have example from daily life, which is the first velocity of car and the second is train acceleration. Okay guys, in this slide, I would like to tell you about a few steps to solve the question about analysis of function 2. The first step is find the x-intercept, which is y equal to 0, and x-intercept, which is x equal to 0. The second step is find vertical asymptote, which is q equal to 0, and horizontal asymptote, and its analysis. The third step is find a critical point, and the next step is find the intervals increasing or decreasing. The next step is find the extremum point, And the next step, find the interval, which is concave up or concave down. The next step is find the inflection point, and the final step is sketch the graph.
Okay, now we move to the problem statement of the analysis of function 2. Okay, here, given fx equals to negative x over 1 minus x plus 4. Okay, now this is the problem solution. The first one is we need to find the x and y intercept. As usual, if you want to find the x-intercept, we need to use fx equals to 0, and we got the answer. And y-intercept is easier than x-intercept, which is we need to substitute the x with the 0. The second one, we need to find the vertical and the horizontal asymptote. To find the vertical asymptote, we need to let hx equals to 0, which is our hx here is 1 minus x. And the horizontal asymptote, we need to use a limit of function x approach to plus minus infinity. Number 3, we need to determine the interval which is increasing or decreasing. The first step, we need to find the f prime x. To find the f prime x, we need to use the formula that vu prime minus uv prime over v square. After we find the f prime x, the second step is we need to let f prime x equals to 0. The answer here, we got x equals to 1. X equals to 1 goes to the interval, and then we need to choose our test value and then do the calculation. Both of interval I got decreasing, so there is no increasing in this interval. Number 4, we need to find the concave up and concave down. The first step here is we need to find the f double prime x first. To find the f double prime x, we need to use the f prime x previous. After that, step 2, we need to let f double prime x equals to 0. Here, I got x equals to 1. And then we're going to do the interval, test value, and the sign of f double prime x. And the answer I got, the concave up equals to 1 and infinity. Concave down equals to negative infinity and 1. Number 5, we need to find the inflection point, if any. In the previous, I got x equals to 1, so we're going to substitute the x with the value that we got before. In this function, I got no inflection point. Lastly, we need to sketch the graph. Using all the information from 1 to 5, this is the graph that I got.
Okay guys, after we have discussion about analysis of function 1 and analysis of function 2, what we can conclude as a conclusion is the first conclusion is analysis of function is used to solve problem in daily life. For example, calculation of speed, acceleration and velocity. The second conclusion is we can identify either the data is increasing or decreasing according to the graph. The final conclusion is successfully solve problems related to the analysis of function. Okay guys, that's all from us. Thank you. Thanks for watching. Bye.